Now in number 2, find n when 3 power 17 is the nth term of the geometric sequence. Here 27 over 9 is the same as 81 over 27. It is a 3. So r is a 3. You have the choice to use u0 or u1. So let us go to u1 because I know students like the first term to be u1. So I want the position of the term, so it's equal 3 power 17. So I put 3 power 17 here. The first term here is 9, as you can see, r power n minus 1. So rn minus 1 equal 3 power 15, because if you do it, it's 3 square over 3 square, 3 power 15. So n minus 1 is 15, so n is 16, so it will be the 16th term. Find n when 1 over 24, 1 over 2 power 14 in the ninth term of the geometric sequence. Here r is half, as you can see. So 1 over 2 power 14 is 8 over 1 over 2 power n minus 1. Here it's 2 cube. So 1 over 2 n minus 1 is 1 over 2 power here. If you add to it 3, 2, because 2 cube, 17. So here you have a power 17. So n minus 1 equals 17. So n is 18. Now we're going to do this problem. The third term of a geometric sequence is 18, and the fifth term is 162. So here, because you have the third and the fifth, you can see you can use this one. Here you put the fifth, here you can put the third. u5 equal u3, and you do like in arithmetical sequence, 5 minus 3. The fifth term is 162. The third term is 18, r squared. So r will be plus or minus 3. Now, if you want to find the first term, you have two choices, because you can take r one time is a 3 and one time r is minus 3. So you can use u3 or u5. If you want to use u3, equal u1 r power 2. So 18 equal u1 times 9. So u1 equal to 2. And if you want to put negative also, minus or plus r power even, it will be positive. The most important, if you want to prove that Vn is a geometric sequence, you need to show that Vn plus 1 over Vn is a constant number r, which is called common difference. For arithmetical sequence, you need to show that Vn plus 1 minus Vn is a constant. Now let us see a problem of sequence. Consider the sequence un defined by u0 equal minus 3 over 2 and un plus 1, 2 over 3 un minus 6. You can see that un is a recursive formula. Our aim is to write it in explicit form. So let us see how we're going to write it in explicit form. We have Vn equal to un plus 6. Show that Vn is a geometric sequence and calculate its first term. To prove that Vn is a geometric sequence, you do Vn plus 1 over Vn. So Vn plus 1 is equal to un plus 1 plus 6 over 2 un plus 6. But what is un plus 1? It's 2 over 3 un minus 1. So if you put here 2 over 3 un minus 1 times 2, you're going to get 4 over 3 un minus 2. Plus 6, you have 4 over 3 un plus 4 over 2 un plus 6. So now if you want to do the calculation, since this is 100% is geometric sequence, so we said it's 4 over 3 un plus 4 over, so if you do it here, 4 over 3 un plus 4 over 2 un plus 6, put coefficient of un up and down in factor. So here 4 over 3 un plus 4. Check 4 over 3 times un is 4 over 3. 4 over 3 times 3 is 4. And down put 2 in factor. Always these 2 will cancel out. Okay, 4 over 3 over 2 equal 2 over 3. Always you're going to get this number. So since Vn plus 1 over Vn equal to a constant number, we say that Vn is a geometric sequence. We need to find the first term. To find the first term of V, we need to know the first term of U. The first term of U is minus 3 over 2. So if you put here U0, so V0 will be 2 into minus 3 over 2 plus 6. If you replace here minus 3 over 2, so it will be minus 2 plus minus 3 plus 6, so it's 3. Write Vn and Un in terms of n. So Vn is a geometric sequence. First term is V0. So Vn equal V0 r power n. R is 2 over 3 power n. Since Vn we can write Vn in terms of n. So we're going to replace now this Vn here. So you're going to get 3 times 2 over 3 power n equal 2un plus 6. So what you're going to get, you take the 6 to the other side and you divide it by 2 to find un. You're going to get 3 into 2 over 3 power n minus 6, and you divide all by what? By 2. So this will be un. So what before un was written in recursive form, now un is written in explicit form. Now the question, study the variation of un and Vn. So Vn plus 1 minus Vn, we use the explicit form. So you add n plus 1 because I want Vn plus 1 minus Vn. So as we said, we split here. So we write 3 into 2 over 3 power 1 like we did before in variation into 2 over 3 power n. So it will be 2n because 3 and 3 cancel out. 2n, 2 minus 3, it will be minus 2 into 2 over 3 power n. So this is decreasing less than 0. And for un plus 1 minus un, we do the same story. You can check it by yourself. It is decreasing. Now they want us to find the limit of un and Vn as n tends to infinity. Let me delete everything. So if you want to find the limit of Vn, any number of the form 0 point power infinity is 0. 0 point times 0 point times 0 point, the number will be 0 times the 3 is 0. And for un here, this is 0 times 3 over 2, 0 minus 3, so the answer is minus 3. Now, most of the problem you're going to face are economical questions. The director of a store notices that the store loses 25% of his clients. So what does it mean? Loses, and if you want to find the first year, so 100 minus 25 over 100 from the year before. If the first year their client was 1,600, so the year after it will be 100 minus 25 over 100 times the year before, and he gained 800 new clients. So what will be U1? It will be 0.75 U0 plus 800, and U2 what will be? The same story, 75% of the year before, which is U1, if in the second year, the year before U1, and he's going to gain 800, so the answer will be 2,300. Show that un plus 1 can be written recursively this form. 100% true. Why? Because un plus 1 equal, compared to the year before, they said they lose 25%, so 100 minus 25 over 100, un plus 800. Now they gave us another sequence. We want to show that this sequence is geometric. So you do Vn plus 1 over Vn, which is 3,200 minus un plus 1 over 3,200 minus un. But un plus 1 is what? 0.75 plus 800 minus 800 because you have minus before. So if you put coefficient of, if you do it here, 0.75 un plus 1 minus 800. Okay, so you're going to get 3,200. So this is un, sorry, not un plus 1. This is un. This is wrong. So if you continue, what you're going to get? You're going to get 0.75. You can check it by yourself. So Vn is a geometric sequence. This is the ratio. We can write it Vn equal V0 R power n. Directly we can write un in terms of n. So un before was here, as you can see, here it was recursive. Now we wrote it in explicit form. So this is the main idea of sequence. Thank you for listening.